My name is Greg Singer, and I'm the project manager for the Canadian arm of the International Barcode of Life project, here at the Biodiversity Institute of Ontario. I'm here to talk about our paper, Barcoding of Life to Conserve Biological Diversity Beyond the Taxonomic Imperative. Carl Linnaeus began classifying organisms about 250 years ago, creating a new field of science called taxonomy. His scientific descendants have now described about 1.7 million species, which is quite an amazing accomplishment. But there may be 10 to 100 million species on the planet, so at this rate it would literally take thousands of years to catalog all of the Earth's biodiversity. And of course, sadly, many of these organisms are going to be extinct by the time taxonomists get around to looking at them. Human activities are causing extinctions at rates much faster than we've observed in the fossil record. Some estimates suggest that about a third of the Earth's species may be extinct by the end of the century, without ever having been studied or protected. DNA barcoding is a technique to help us study, classify, and understand all of the Earth's biodiversity, including those 90% that we know nothing about. DNA barcoding is based on this simple observation that a short and standardized piece of DNA contains enough information to differentiate species from each other. We've now applied this concept to all sorts of life: plants, birds, insects, mammals, and even fungi. In the vast majority of cases, DNA barcodes are capable of distinguishing species and can even identify new ones, allowing taxonomists to focus their efforts on the groups of organisms that hold the most potential interest. DNA barcodes are gene sequences and are therefore digital data, basically a string of A's, G's, C's, and T's. That makes barcode data useful for rapid, standardized, automated identification, and the monitoring and managing of biodiversity can be a lot easier. Various studies have also used this technology to expose market fraud, track the illegal trade of rare and endangered species, and fast-track the identification of disease-causing organisms and their vectors. Although this project was started here in Canada, this country holds only a small fraction of the Earth's biodiversity, and so we knew from the very beginning that this had to become an international effort. For this reason, we began the development of the International Barcode of Life project, or IBOL for short, which will launch in September of 2010 and will begin as an alliance of 26 countries. The basic structure of IBOL is one where the wealthy but biodiversity poor countries, like Canada and the United States, will have the DNA sequencing factories and computers to generate the barcode records and store them in a public database. Meanwhile, less wealthy but biodiversity-rich countries will participate in the project by collecting and cataloging their wonderful biodiversity resources and collaborating in the sample processing and analysis. Since 2003, we've been able to generate nearly 1 million barcode records representing more than 100,000 species. The goal of the International Barcode of Life project is to ramp up this rate of production significantly, retrieving barcodes from 5 million specimens representing 500,000 species, and all in just 5 years. These goals are going to take a lot of work and organization to attain, but we believe it can be done, and the benefits to society when it is done will be immeasurable. This project involves collaborations and exchanges of biological materials and information between the developing and the developed worlds, so our work must consider the complexities that come with that arrangement. We work very closely with the Convention on Biological Diversity and aim to contribute to its 3 main objectives: conservation, sustainable use, and equitable sharing of the benefits that arise from this project. The third objective, often referred to as access and benefits sharing, or ABS, belongs to the sphere of policy and law. Now, scientists don't normally spend a lot of time thinking about these issues, but they are of the utmost importance in a large scientific project like this. In the past, many valuable species were exported from developing countries during their years as colonies. And these experiences have motivated some countries to enact stringent laws that do not allow the export of biological specimens or materials, even for scientific research purposes. Ideally, national regulations on access and benefits sharing will be crafted in a fashion that enables the taxonomic research necessary for conservation management, especially in biodiversity-rich equatorial countries. To discuss these issues, the International Development Research Centre in Canada sponsored a panel discussion at the 3rd International Barcode of Life Conference during the fall of 2009 in Mexico City. The panel included a lawyer, an economist, and a sociologist, all from developing countries with experience in access and benefit sharing. The paper I'm describing today includes summaries of the presentations they gave in Mexico City. The results of this discussion were an eye-opener for me personally, forcing me to think about this project in new ways, with discussions about the legal, economic, and sociological dimensions of the project. What access and benefits sharing arrangements are being proposed for IBOL? The involvement of local researchers and research institutions is a critical element in the project. They are full partners, and they gain the benefits in the form of training and access to advanced laboratory techniques and IT facilities. The barcode records themselves are available online through GenBank and through our own informatics platform, the Barcode of Life Data Systems, or BOLD for short. This data contributes to the understanding that provider countries have of their biodiversity and improves their ability to conserve and manage it. The protocols we use to obtain DNA barcodes from specimens are all published and made freely available to the public. In addition, we are committed to publishing papers in open access journals so that developing nations have access to the information generated through their resources. Now, it's not often that scientists like myself are forced to think about science policy. The temptation is all too great to simply rush in and get the results. But these ABS issues are important ones, especially for the IBOL project. It's for this reason that we feel it's extremely important to engage provider countries fully and to communicate the benefits of this research and also the potential pitfalls. I hope that this video and the accompanying paper have been thought-provoking. I'd like to invite you to visit our new YouTube channel with new content every week covering a wide range of topics, not just science policy. And also, please be sure to check out some of our other websites that explain DNA barcoding and some of the results that we've generated from the data. Thanks very much.